The nascent, meaning newly formed, chylomicrons, synthesized in the intestine from dietary lipids, and VLDL, synthesized in the liver from endogenous lipids, eventually reach the blood circulation. At the time of entering the blood, chylomicrons and VLDL have similar but slightly different compositions. Each nascent chylomicron particle primarily has a single molecule of ApoB48 lipoprotein and a triglyceride to cholesterol and cholesterol's esters ratio of approximately 10:1. Likewise, each nascent VLDL particle primarily has one molecule of ApoB100 lipoprotein and a triglyceride to cholesterol and cholesterol esters ratio of approximately 5:1. While in the blood circulation, the two particles undergo similar changes. The particles first acquire multiple copies of ApoC2 from HDL, making them mature particles. The mature chylomicron now has two types of apoproteins, one molecule of ApoB48 and multiple copies of ApoC2. Likewise, the mature VLDL has two types of apoproteins, one molecule of ApoB100 and multiple copies of ApoC2. To simplify the illustration, we'll just focus on the VLDL particle for now in this animation. However, please remember the chylomicron particle also undergoes similar changes. The ApoC2 found on the particle interacts with the lipoprotein lipase enzyme found on the endothelial cells lining the vessel wall. This activates the enzyme. The enzyme now breaks down the triglycerides in the particle into free fatty acids and glycerol. The free fatty acids diffuse across the endothelial cells into the surrounding tissues. The glycerol is carried back to the liver through the blood. As more and more lipoprotein lipases break down the triglycerides, the particles continue to get smaller and smaller in size. Gradually, the ApoC2 molecules get transferred back to HDL in exchange for another apoprotein called ApoE. Eventually, all ApoC2 is exchanged for ApoE, and the lipoprotein lipase cannot act on the triglycerides in the particle anymore. The particles are now called remnants. At this stage, each chylomicron remnant has one molecule of ApoB48, a few molecules of ApoE, and no ApoC2. The VLDL remnant, also called IDL, meaning intermediate density lipoprotein, is similar to the chylomicron remnant. Each IDL particle has one molecule of ApoB100, a few molecules of ApoE, and no ApoC2. Both remnant particles now have approximately a 1:1 ratio of triglyceride to cholesterol. At this stage, the particles are small enough to pass into the space of Dicey through the fenestrated endothelium lining the blood vessels in the liver. Once in the liver, the particles get internalized into hepatocytes via receptor-mediated endocytosis. The ApoE on either particle binds primarily to the LDL receptor-like protein, called LRP in short. ApoB100 on the IDL particles binds to LDL receptors. These bonds are responsible for the receptor-mediated internalization of the remnant particles. While all of the chylomicron remnants get removed by this process, only approximately 50% of the IDL remnants get internalized into the liver. The remaining 50% get processed further and converted into the cholesterol-rich particles called LDL, meaning low-density lipoprotein.